Alright, so this is going to be for the EOC review, going through the same things we were working on in class. We have here number 1, which situation is best modeled by the expression 2 plus x. I think all of us did a pretty good job with agreeing that that was going to be C. Fatima is 2 years older than her sister Delilah, who is x years old. Okay, so next, again, algebraically, this is a problem that we're going to solve where we're going to, let's just rewrite the problem here, 8x minus 2x plus 3, and that equals 4x plus 1. So we're going to distribute this negative to both of these terms. So we have minus 2x minus 3, and then we just bring down what we had here. 8x equals 4x plus 1. Okay. Now we're going to go ahead and combine like terms. So we have 6x minus 3 equals 4x plus 1. Alright, from here we're going to subtract the 4x from both sides, and we'll get 2x. We're going to add the 3 to both sides and get 4, so x equals 2. So our answer here is H. Okay, so there's going to be certain things that are going to be on this test that may not necessarily have been covered explicitly in class, but there are some prior knowledge, or there is some prior knowledge that we should bring to it. Whenever we look at the word perimeter, we're talking about adding up all of the sides together. So in this case, if I'm looking for an algebraic expression for this, I'm going to add up all of the sides plus 2m minus 1. So I added up this side with this side with this side. And so we combine like terms. Well, we have 3m minus m, which is 2m. 2m plus 2m is 4m. Then we have 4 minus 1, which is 3. So that's going to give me A. Okay? Next. Number 4. Okay, so we have to remember that on a graph, so we have our x, we have our x and y axis. Okay? This is our y-axis, this is our x-axis. And so again, we have quadrants to this. So we have a first quadrant, a second quadrant, a third quadrant, and a fourth quadrant. So if you are given this point, 2x and negative x, if I was to plug in negative 1 for x, we have 2 times negative 1, plugging it in for x, comma, negative, whatever the x value is, negative 1. So we get negative 2, positive 1. So if I plot that, we have negative 1, negative 2, and positive 1. And we can see that that's in the second quadrant. Okay, so number 5, so the time that it takes for Jarvis to get to school on his bike is 1/3 of the time it takes to walk. Which equation can be solved to find the time it takes Jarvis to walk to school if he can bike there in 5 minutes? So I want to know, what's the comparison of walking to riding a bike? Well, if it takes 1/3 of the time, well, then that's going to be 1/3 of the time that it takes to walk. Okay, so if it takes us 12 minutes to get there, actually, no, I'm sorry. we're comparing this to the time that it takes here for the 5 minutes. So we have 1/3 of the time, and that's going to equal the total time that it takes there on a bike, which is 5. So our answer is C. Just know that if you have 1/3 of the time, if I take 1/3 of 9, well, that's going to be 3, because I multiplied this, 1/3 of whatever that value is. All right, so here we have the dreaded fractions. And what we're going to do is we're going to solve this for x. So we have negative x over 7 minus 2 over 3 equals 4 over 21. Well, the first thing I want to do is I'm going to add this 2/3 to both sides. So I'll rewrite this equation over here as negative x over 7. This canceled out, and I'm left with equals 4 over 21 plus 2 over 3. Now, in order to add the fractions, we need common denominators. My least common multiple of 21 and 3 is 21. So my common denominator is going to be 21, so we can leave this alone. And then we're going to multiply the top and the bottom by 7, so I can get the common denominator of 21 here. So we get 14 over 21, and that is plus 4 over 21, and that equals negative x over 7. So when we add this up, we get 18 over 21, and that equals negative x over 7. So I'm going to take that up here. We have negative x over 7, just kind of rewriting what we had. Now, in order to get x by itself, I want to multiply both sides by a negative so I can get it positive. Negative times negative is positive, and 7, so I can cancel my 7's out. So I'm going to multiply both sides by negative 7. So we get x equals negative, I think it's, let's see, 18 times 7 is going to give me 126. So we have negative 126 over 21, which gives me negative 6. So my answer, negative 6. Be careful, because something like that is there to almost trick you. It's saying that you did not multiply by the negative. You only multiplied by the 7. So we lost the negative in the process here. Number 7. So it's a proportion. We have 9 out of 100 people are left-handed. So we have the number of left-handed people over the total people. So we're saying that 9 out of the total are left-handed. So the next sentence is, out of a population of 1740, a total population of 1740, how many people are likely to be left-handed? Likely to be left-handed. So we have x. So we're going to multiply. Cross multiply here. And we have 100x equals, let's see here, we have 9 times 1,740. And that's going to give me 15,660. So I'm going to go ahead and divide both sides by 100. And so coming back to the calculator, we're going to divide by 100. 15,660 divided by 100. And that gives me 156.6. So again, because we're talking about the likelihood, we can round this up to 157. Okay. So with absolute value, you have to remember that when we have an absolute value equality, if we take the basic concept of the absolute value of x equals 6, that presents two conditions. X could be equal to 6, and x could be equal to -6, because if we plug either one of those back in, we're still going to get a value of 6. So what we have to do is solve for the absolute value. So we have 2 times x plus 1 equals 8. I'm going to divide both sides by 2 so I can solve for the absolute value. And I have the absolute value of x plus 1 equals 4. Now that I've solved for the absolute value, same thing here, I'm going to set up two conditions. Whatever is in the absolute value equals positive 4, and whatever is in the absolute value equals -4. So if I subtract 1 from both sides, x equals 3. If I subtract 1 from both sides, x equals -5. And so we see here that my answer is J. Which is not a solution to the inequality. Well, all we want to do here, we can solve this pretty easily. We could say 4x minus 7 less than 5. So if I was to add 7 to both sides, we get 4x is less than 12. So x is less than 3. So I want to find all values of x that are less than 3. Well, -2 is less than 3. 0 is less than 3. 1 is less than 3. But 3 is not less than 3. 3 is equal to 3, but this is strict. Okay, so next, number 10. Number 10, we have Lorena and Sebastian are both 5 years old. Every year, they each get together, get a cash present from their neighbor. Sebastian gets $1.50 for every year in his age, and Lorena gets $20. How old will they be when Sebastian gets more money than Lorena? So again, we're looking at an inequality here. I want to know how much money is, or how many years old will Sebastian need to be until he actually gets more money than Lorena does. Well, if Sebastian gets $1.50 per year, okay, $1.50 per year, then I want to know how many years will it take for him to have more money than Lorena, which is $20. Okay, remember, this didn't say $20 per year. This is a one-time payment right here. So it becomes a simple solution. We're just dividing both sides by 1.5. And at that point we have y is greater than 20 divided by 1.5, which should be 1.5, 13.3. So we have 13.3. Now the question is, when we look at the answers here, we have a 13, and we also have a 14. Now you have to be careful because it says Sebastian has to be at least, hang on one second. Sorry. So it says he has to be greater than 13.3 years old. Not greater than 13 because we still have this 0.3 right here, but greater than 13.3 years old. So we go to the next age, which is going to be 14. And so Sebastian has to be older than 14 years and older, okay, in order for him to have more money. 20 could be one of the answers, but it's not the minimum answer. It's not the lowest age he could be until he starts to have more money than Lorena does. Okay. Sorry about the interruption. I had somebody at the door. Next. All right, so again, same thing. We have an absolute value here, okay? But this time, instead of having an absolute value equality, we have an absolute value inequality, which is less than. So again, key to remember. If I see a less than and an absolute value, less than is the conjunction and. Greater than is the conjunction or. The reason why is because if we solve this, we have the absolute value of 2x minus 5 is less than -1. So we know we have to at least solve for the absolute value. So we're going to add the 5 to both sides. And we have the absolute value of 2x is less than 4. So again, if we have a number line, okay, then we're going to have this absolute value says whatever is in the absolute value, whatever is in here, has to be less than 4 units away from 0 in both directions. It's a distance. Less than 4 units away from 0. So, we have 2x has to be less than 4. So we have 2x is less than 4. And we have 2x has to be greater than -4. 2x has to be greater than -4. So we can solve this. X is greater than -2 and x is less than 2. And so we can see here that my answer is C. Notice that because if you're able to recognize the and the or from the beginning, I can eliminate 2 of my options right there. Okay. So which of the following statements is true? All right. So dependent and independent variables. Dependent variable is our y value. Independent variable is our x value. Okay? If I have an equation, y equals 2x, the value of y is dependent on what number I choose to put in for x. So we look at our answers here. Which of the following statements is true? The dependent variable is the input of the function. Well, let's think about input for a second. So we have this function here. All right. We have an input into the function and we have an output. All right. Well, our input is the independent value, our x's, which can be anything we want, and it goes through the function machine, and then it comes out as the dependent variable. Well, it says here the dependent variable, which is y, is the input of the function. Well, that's x. That can't be right. Y is not x. The dependent variable, y, determines the domain of the function. Well, we know that domain represents x, so that's not correct. In f of x equals 2x plus 1, x is the dependent variable. Not correct. Again, x is not the dependent variable, y is, or f of x. In f of x equals 2x plus 1, f of x is the dependent variable. And again, we got to that point by elimination, but we realized that whether we're talking about y or we're talking about f of x, those are still both the dependent variables. So if we're looking at which function has 0, 7 on its graph, that means that if I plug in, let's take b for example. We have y equals x minus 7. Okay? So if we have that, what that's telling us is, let's see, if we were to take, let's see here. So if we were to take y equals x minus 7, okay? What this is saying is that if this is our function, 0, 7 is on its graph. So that means that if I came back to this function, the point 0, 7, which is right here, this point right here is on the graph. Well, it's not on here, is it? Okay? And we can tell that algebraically by coming in here and plugging our values in. We are looking to see, does the point 0, 7 fit in this line? So we plug in 7 for y, 0 for x. And we see, is that a true statement? Is 7 equal to negative 7? And that's not correct. Therefore, this does not work. So we have negative 3x plus y equals 7. So again, using my ordered pair, 0, 7. If this is going to be on the line, it has to be true for both sides of the equals after I have plugged it in. So we have negative 3. We're plugging in 0 for x, plus we're plugging in 7 for y, should equal 7. Well, in fact, here we see that 7 equals 7, therefore my answer is A. Okay, so we talked a little bit about scatter plots. We talked about correlations. Okay, correlations. If our data starts to have a downward trend and it's condensed in a certain group, then that's a negative correlation. If we have data that looks like it's going grouped positively, it's a positive correlation. Okay, so we can see here that we can eliminate immediately these two answers right here because both of them are asking that it has a positive correlation. Well, that's not true. So let's look at our options now. The distance traveled versus the cost of gas. Okay, the distance traveled versus the cost of gas. Now again, if we just think about negative correlation, one has to do with the other. So if my distance increases, does my gas decrease? No, it does not. If my gas increases, does my distance decrease? No. So it's not going to be F, and we're left with H. Time traveled versus distance. Okay? So the more I travel, the less distance I have. Okay? So that makes more sense to us. All right, so a function has an x-intercept of 3 and a y-intercept of 2. Which of the functions could be this function? So again, when I have an x-intercept, so the x-intercept is where the line crosses the x-axis. Okay, this is an x-intercept right here. Notice that my y value is 0. So my y value is going to be 0. Whereas my y-intercept is where the graph crosses the y-axis. So in this case here, it crosses the y-axis at 0, -7. Notice that my x value is 0. So then we look at each one of these equations right here. Now we can genuinely solve for each one of them. Okay? So let's look at the first one here. We have 4 plus 3x equals 2y. So if I went ahead and plugged in my x-intercept, my y value should be 0. So if I plugged in 0 for y, then we have 4 plus 3x equals 0. So we subtract 3x from both sides, and we get 4 equals -3x. We see that this is not going to turn out to be what we're looking for. We're looking for an x-intercept of 3. So we know that this is not going to be the answer. Okay? So looking back at the answers here for a second, one that's going to have the x-intercept, if we look at D for a second, we have 3y minus 6 equals 2x. Well, if I put this in standard form, by the way, is ax plus by equals c. Some number a times x plus some number b times y equals c. So I want my x's and y's on both sides and the constant on the other. So I'm going to go ahead and move this guy over here. So we have, and I'm going to move this guy over here by changing the sign. So I'm going to have -2x plus 3y equals 6. Okay, going back to this. I actually wrote the problem down wrong here. Sorry about that. This was actually supposed to say 3y minus 6 equals -2x. So we're going to add the 2x. We have 3y plus 2x equals 6. All I did was just move this over here and move this over here, just changing the signs of both of them. So again, using the cover-up method for x and y intercepts, if I was to cover my y, I have 2x equals 6, therefore x equals 3. If I cover up the x, 3y equals 6, therefore y equals 2. That's my x and y intercepts, so the answer would be D. Alright, so what this is saying is the score for a football game by quarters was recorded as the ordered pairs. In the first quarter we had 7 points, second quarter we had 10 points, third quarter we had 21 points, and fourth quarter we had 21 points. So the relation is a function with domain 1, 2, 3, 4. The relation is a function with domain 7, 10, 21. The relation is not a function. The relation is a function with a domain all the x's between 1 and 4. Remember, domain is the x values. So my domain for these ordered pairs is 1, 2, 3, and 4. So I can immediately take out this guy right here and this guy right here. So now I'm down to 2 answers, whether it's a function or not a function. Now again, if we map this, 1, 2, 3, 4, this is my domain, and we have a range of 7, this is my y values, 10, 21. Okay, 21 is repeated twice, we only have to carry it once right here. This says that 1 is mapped to 7, 2 is mapped to 10, 3 and 4 is mapped to 21. Now what that means is, if I put a 3 in, I get a 21 back. If I put a 4 in, I also get a 21 back. That's okay. It's a function. Okay? Where it would not be a function is if 1 went to 7 and 1 went to 10. I can't have a function y equals 2x and put some number, let's say 1, in for x, and get 2 different numbers for y. Y equals 2, and it only equals 2. It doesn't equal 2 different numbers. That's what we're saying right here. When I put a number in for 1, or for the domain of x, I get a 7 and a 10 back. That means it would not be a function. Okay? However, in this case right here, because I have a 3 mapped to 21 and a 4 mapped to 21, that is a function. So our answer is F. Alright, so one of the equations that you're going to be given on the EOC, I think, in regards to the formulas, is the point slope formula. Y minus y1 equals m times x minus x1. Okay? And this is saying, I want to find the equation of a line that is perpendicular to the line described by y equals negative 1/2 x plus 2. So in my equation here, y equals negative 1/2 x plus 3. My slope is negative 1/2. To define the perpendicular slope, we flip the fraction and change the sign. So now I know that my slope is equal to 2, my x value is 7, and my y value is 1. Now all I'm going to do is simplify. Alright, we're going to do that by distributing. So we have 2x minus 14, and we have y minus 1. I'm going to add the 1 to both sides, and we get y equals 2x minus 13. Alright, to change from f of x equals 4x plus 2 to g of x equals 3x plus 2 is an example of which type of transformation? This is going to be a rotation. We didn't actually go over rotation in class. So this would be the type of question that we might have to guess on. Okay? Because we only did translations, reflections, and vertical stretch and compression on quadratic formulas, on quadratic equations. We didn't go over too much in the way of linear transformations. Okay? But let's come back here for a second. We have here the graph of 4x plus 2. Okay? Let's get rid of our Can we get rid of our Okay. So now we have 4x plus 2, and we also have the graph of 3x plus 2. Y equals 3x plus 2. Okay? Now, what happened? The only thing that happened was my y-intercept is the same. My slope was 4, so that's a steeper slope, and then it went to a less steep slope of 3. So my line simply rotated. It went from a slope of 4 to a slope of 3. Okay, so the line just rotated down with a lesser slope. So in this case right here, we can see that we have a rotation. This is where having the graphing calculator might help us out. Because if we had the graphing calculator, you could do this inside the test itself. All right, you have this y equals function. Let's clear out both of our functions here for a second. All right, we had 4x plus 2. Okay, so we can see what that graph looks like right here. All right, this is my graph. Then I'm going to come over here. I'm going to add the next graph. Okay, so we're going to scroll down, and we have 3x plus 2. All right, we can see that everything is the same except for it just rotated around this one point right here. So we have a rotation. Okay, a local video store has 2 new renting plans. Plan A charges $10 a month and $2 for every movie. Plan B charges $40 per month. But then each movie's rented is only 25 cents. How many movies must be rented in a month to make Plan B cheaper? Plan B the cheaper option. So let's just look at our plans. We have Plan A. Okay. Plan A is $10 a month plus $2 for each movie. Plan B is $40 a month plus 0.25x, 25 cents each movie. How many months will it take where Plan B is the cheaper option? So then we have the inequality here. Okay, so we're going to subtract the 0.25x from both sides. And I have 1.75x. We have this 10 here greater than 40. So we're going to subtract the 10 from both sides. We have 1.75x is greater than 30. Divide both sides by 1.75. So we have 30 divided by 1.75, and that gives me 17. Okay? So again, we're back at that question. Okay? When is it cheaper? All right? At 17 months? Well, not necessarily, because we're at 17.14 months. So really, at 18 months, it becomes cheaper. We're going to classify the system here. Again, remember, if it's inconsistent, that means my two lines will never intersect, which means they are parallel, which is same slope. Okay? That's inconsistent. All right? Then we have consistent systems. Let's do that. All right? A consistent system is a system that has a solution. However, we have two different types. We have independent, where it has one solution. Okay, independent. Think one, independent. Okay, this is consistent, independent. And then we also have consistent and dependent, which means that it's the same line, just one on top of the other. Okay? This one has one solution. This one has infinitely many solutions. So we look at this. I want to look at my slopes. I have different slopes. So that tells me it's not inconsistent. Because I had the same slope, it would be parallel. So again, going back to a graphing calculator again, I can look at this and tell. We have y equals 2x plus 3, and then same y-intercept, but a negative slope, and I'm going to graph them. And I can see here that I have one solution. So therefore, I have a consistent and independent solution. All right? For these right here, which point is a solution of this system of inequalities? All we need to do is just plug in these points for each one of these systems. Okay? For example, I have the equation, I have the system here, y, let's just make it a little bit bigger so we can kind of erase as we go. Y minus 3x is greater than or equal to 2, and y is less than or equal to x plus 9. So let's say we plug in negative 2 and 8. Let's see what happens. So we're going to plug in negative 2 and 8. So we had negative 2. Okay. We're going to do the same thing down here. We're going to plug in negative 2 and 8. Okay. We'll see if it works. So here we have negative 24. Negative 2 minus 24 is negative 26. And that has to be greater than or equal to 2. Well, immediately that's not true. Therefore, this point does not work. Now, if you plug in each one of these into that system of inequalities, we will see which one works. And ultimately, 21, B is the answer. If we were to plug in B into this inequality, it would work for both of them. So that means that it's the solution. Which of the following pairs of points is the solution to the system of equations? Well, again, you have a quadratic equation right here, and you have a linear equation right here. My suggestion again, look at the calculator. Okay? Plug in your system of equations. We have x squared minus 1, and we have negative x plus 5. Let's graph these. So we have a parabola and a line. Okay? So now look at my answers here. It looks like we have negative 1, negative 2, negative 3, and then we go up 1, 2, 3, 4, 5, 6, 7, 8. Okay? Negative 3, 8. All right, so I'm feeling pretty good about this one. and this one. Let's see what the other solution is. So now we have 2, 3. Okay? Bingo. I got my answer right here. Now again, we can plug in both of these values, both of these ordered pairs, into each system. When I say that, it has to work. Negative x plus 5. So that means that both ordered pairs, negative 3 and 8, and 2 and 3, have to satisfy both equations in this system. It's easier to graph it. Which of the following is not equivalent? Remember exponential properties. A negative exponent flips it. If I have 3 to the negative 2, I flip this and make it a positive exponent. 1 over 3, positive exponent. If I have 3 to the 3 over 4 to the negative 5, that's the same thing as 4 over 3 to the 5th power. Same thing happens here. We're going to flip this 4x to the 5th over x squared y, and we're going to make our exponent positive. Now again, remember with exponents, I have 4 squared, and the exponent of 2 goes to x to the 5th. X to the 5th raised to the 2nd power, all over. This 2 goes to this as well. So we have x squared raised to the 2nd power and y raised to the 2nd power. So we have 16 x to the 10th over x to the 4th y squared. Now again, when I have the same base and different exponents over a fraction bar, we subtract the exponents. So we get 16x to the 6th over y squared. Now let's see which one's going to kind of satisfy one of these right here. Okay? Well again, if we look at this, I was able to kind of answer that question immediately without even having to go back any further. I kind of went along with it because I wanted you to see the exponential properties that goes along with simplifying this. But all we had to do was flip this, make it a positive, and I found my answer. Next. 24. Looks terrible, doesn't it? Okay? Well, let's simplify this for a second. So we have x to the 1/4 raised to the 8th, and we have the cubed root of x cubed. Well again, remember the nth root of x is the same thing as x to the 1 over n. So we have the third root of x cubed, which is the same thing as x cubed raised to the 1/3. Now this power, we multiply, so we get x to the 8 over 4, which is x squared. Again, we multiply these. 3 times 1/3 is x to the 1st. And then when I'm multiplying the same bases, I can add my exponents, and we get x cubed. We see here the answer is F. Quartic trinomial. This tells me number of terms and the exponent. Quartic means 4. Fourth degree exponent, number of terms. Well, the highest order here is 5. So this is not a quartic. The highest number here is 3. It's not a trinomial. The highest number here is 4. This is a trinomial. The highest number here is 4, but this has 4 terms in it. So therefore my answer is C. Quartic trinomial. Volume equals. Volume equals length times width times height. One of the things that you'll be given in your rules. So, when we're looking at this right here, we are multiplying the length, x plus 2, times the width, 5x minus 1, times the height. Okay? Now this is where it gets a little tricky. We're going to FOIL these two right here. So we have x times 5x. First, we have 5x squared. Outer, x times negative 1, negative x. Inner, 2 times 5x, 10x. And then we have last, negative 2. Combine like terms, we have 5x squared minus or plus 9x minus 2. Now we have to multiply it by x minus 2. So again, think about distributing. If you were distributing that x minus 2, you would distribute it to each term. Okay? So the same thing happens. We have 5x squared times x minus 2. We have plus 9x times x minus 2 minus 2 times x minus 2. Okay, so we're going to distribute this right here. So we have 5x squared times x, which is 5x cubed. 5x squared times negative 2, negative 10x squared. 9x times x, 9x squared. 9x times negative 2, negative 18x. Negative 2 times x, negative 2x. And negative 2 times negative 2, positive 4. We'll combine our like terms. We have 5x cubed. Negative 10x squared plus 9x squared is negative 1x squared. Negative 18x minus 2x is negative 20x plus 4. And we have our answer, G. Which has a GCF of 5x. Both terms need to have at least x in them. So I can rule out this one right here. All right. GCF of 25x squared and 50x is 25x. 5x squared and 20x is 5x. 4x cubed and x squared is going to be 8x squared. So my answer is B. That shouldn't be too difficult for us. All right, we're going to factor here. Because my leading term is going to be something other than 1, we are going to find two numbers. Okay? Remember this. We'll rewrite this down here. Two numbers. That when I multiply them, they're going to equal 2 times 30, which is, when I multiply them, they're going to equal 60. And when I add them, they're going to equal 17. So my multiples of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Well, immediately I can see now that if I add 5 and 12 together, I get 17. So I'm going to split this. I have 5x plus 12x. We'll bring these down. Okay, now we're going to factor by grouping. So we're going to group these two together. So my GCF of 2x squared and 5x is just x. I'm going to divide both of them by x. And I get 2x plus 5. My GCF of 12x and 30 is going to be 6. I'm going to divide both of them by 6. And I get 2x plus 5. I can factor out the 2x plus 5, and I'm left with x plus 6. 2x plus 5, x plus 6. Okay? Alright, so x squared plus bx plus c. What values of b and c would make a perfect square trinomial? Okay? So that means that if I have x squared plus bx plus c, I have to have a combination of two numbers here. Okay? A perfect square is, we have, let's see, a squared plus 2ab plus b squared. That means that I have a term from both the first and the last are perfect squares, and the middle here is equal to 2 times the first, one factor from the first times one factor from the second. So my last term, c, has to be a perfect square. Well, that rules these two out because these are not perfect squares. So I can look at this one right here. So if I have x squared plus some number times x plus 16, then I have x and x. We have 4 and 4. So the middle here should equal 2 times one factor from the first, one factor from the second. So that should equal 8x. And so that's going to be my numbers. Which of the following statements does not apply to a quadratic function? The vertex is at 0, 7. Okay, well again, vertex is negative b over 2a plus, when I plug it back in, whatever that y value is. Okay? So again, if I was just to look at these answers, vertex 0, 7, let's wait on that for a second. Parabola opens downward. Check. Okay? So that works. We're looking for not, by the way. Its axis of symmetry is y equals 0. Okay, now remember again, axis of symmetry notice that the line y equals 0. Let's go back to our graph here for a second. We have y equals 0. Notice that is the x-axis. Everywhere along the x-axis, y is equal to 0. Is that ever going to be an axis of symmetry? No. Okay. Okay, 31. Which one has the steepest slope? I have a slope of 3/2, slope of 1, 1/2, and 1/5. That is just recognizing that the largest of all of those numbers right here is A. We didn't do completing the square. However, you could do the quadratic formula with this by putting it in standard form and solve it the same way. X squared plus 10x, and I'm going to subtract 39 from both sides to set it equal to 0. If we use the quadratic formula, okay, then we can go ahead and plug our values in and see which one we have for an answer.